Good morning, students. The previous class we have seen the triangle of addition of vectors and the parallelogram of addition of vectors. Now we are going to see the polygon law of addition of vectors. Here I have taken 5 vectors: A vector, B vector, C vector, D vector and E vector. We are going to see the sum of all the vectors using polygon law of addition of vectors. Here you have to note that the second vector, the initial point of the second vector should coincide with the terminal point of the first vector. In this way only we have taken the 5 vectors. So take the first two vectors, A vector plus B vector. How it will be written? OA vector plus AB vector. So using the triangle of addition of vectors, this can be written as, you see, the initial point of the first vector, terminal point of the first vector should coincide with the initial point of the second vector. So that is your OB vector. So you take the third vector, A vector plus B vector plus C vector. What is A vector plus B vector? That is OB vector is written plus C vector. What is your C vector? BC vector. So when you add these two, it is nothing but OC vector. Then the fourth vector is added with that. So for the sum of first three vector is denoted as OC vector plus D vector is CD vector. So this is nothing but OD vector. So if you add the fifth vector, so the sum of first four vector is OD vector plus the DE vector has to be added. E vector is DE vector. So OD vector plus DE vector is equal to OE vector. This OE vector is nothing but the sum of all the 5 vectors. Okay, so O is nothing but the initial point of the first vector. E is nothing but the terminal point of the last vector. So the line joining the initial point of the first vector to the terminal point of the last vector is sum of all the vectors. That is the polygon law of addition of vectors. So now here we are going to see the results on vector addition. So vector addition is commutative. That is, A vector plus B vector can be written as B vector plus A vector. Vector addition is associative. That is, A vector plus B vector we can associate together. That resultant is added with C vector. That is equal to A vector plus B vector plus C vector. So first B vector and C vector has to be added. That addition has to be added with A vector. So therefore vector addition is associative. For any vector A vector, we can write A vector plus 0 vector is equal to 0 vector plus A vector is equal to A vector. So you can add any vector to the 0 vector, you will get the same answer, same vector as answer. For any vector A vector plus minus A vector. So the negative of A vector, that is equal to minus A vector plus A vector is equal to 0 vector. So here this minus A vector, that is the negative of A vector, is called the additive inverse. Here the 0 vector is called the additive identity of vectors. So the next topic, we are moving to the scalar multiplication of a vector. It's an important one. So now one vector has to be taken. Let A vector be a vector and M be a scalar. Scalar means it's a constant. Okay, it has only magnitude, so constant has to be taken. So how to multiply this constant with the A vector? So it is denoted as MA vector. This MA vector is a vector. That is called the scalar multiple of A vector by the scalar M. So according to the scalar, this vector will vary. So M is 0. The constant is 0 means this MA vector is a 0 vector. M is positive. That is 2A vector means your A vector and MA vector have the same direction. M is negative means A vector and MA vector have the opposite direction. Then the magnitude of MA vector is equal to modulus of M into modulus of A vector. Okay, modulus of M. There is a constant. If it is positive or negative, we have to write the positive one, modulus of M. And modulus of A vector. Modulus of A vector is nothing but the length of the line segment of A vector. Okay, so the very important result, two vectors A vector and B vector are said to be parallel. The two vectors are said to be parallel means we can write one vector is a scalar multiple of other vector. if we write this result, A vector is equal to lambda into B vector. What is lambda? Lambda is a scalar. So one vector is a scalar multiple of other vector. We can say those two vectors are parallel. If lambda is greater than 0, lambda is positive, both the vectors in the same direction. If lambda less than 0, that is per negative, both the vectors are in the opposite direction. So we are going to see the results, some properties on the scalar the multiplication of vectors. Here we have taken two vectors, A vector and B vector, and the scalars m and n. So we have m into n a vector is equal to m and a vector is equal to n into m a vector. That means m is we have taken as 2 and n is 3. So 2 into 3a vector can be written as 2 3s or 6. 6a vector you can write. That is given m and a vector. That is equal to 3 into 2a vector. So the constant we can make use of anyway. And m plus n into a vector can be written as ma vector plus n a vector. M into a vector plus b vector can be written as ma vector plus mb vector. So next one, we are moving to the position vectors. What is it? Position vectors. So the position vector is nothing but let O be the origin. Let P be any point. Let P be any point. Then the vector OP vector is called the position vector of the point P with respect to the origin. See now, your position vector means we have to take O be the origin. For position vector of A means it has to be written as OA vector. Position vector of B is OB vector. Then the position vector of P is OP vector. So position vector, if it is asked, the origin has to be taken as O. Okay, here let O be the origin, A and B be 2 points. So you take O be the origin, A and B be 2 points. The position vector of A is denoted as OA vector and the position vector of B is denoted as OB vector. You see that? What is OA vector? We have taken the origin as O. So therefore, OA vector is nothing but the position vector of the point A. What is OB vector? Position vector of the point B. See, we'll take the two vectors. Your OA vector as A vector and your OB vector as B vector. Okay, now we are going to find what is AB vector. So I'll join this. Here I am going to use the triangle of addition of vectors. So I'll take OA vector plus triangle of addition of vector means the terminal point should coincide with the initial point. So therefore here AB vector. Okay, that is equal to, if they coincides means your answer is OB vector. So if you want to find AB vector, it can be written as OB vector. This OA vector, if you bring it here, minus OA vector. So AB vector, any vector can be written using position vector. That is OB vector minus OA vector. AB vector can be written as OB vector minus OA vector. Here you see that B is the second point, that is a terminal point, and A is the first point. So AB vector can be written as OB vector minus OA vector. That is the position vector of the second point minus position vector of the first point. That only the result is given. Let O be the origin. Let A and B be 2 points. Then AB vector can be written as OB vector minus OA vector. This is a very important result. And CD vector, if you want to write using position vectors. So position vector of the second point. What is the second point here? D. So it can be written as OD vector minus OC vector. If you want to write PQ vector using position vector, you have to write OQ vector minus OP vector. That the position vector of the second point minus position vector of the first point. In this way you have to write. So using this, the position vector, we are going to find the section formula. you will have two divisions, internal division as well as the external division. So now we are going to see the internal division. Let O be the origin. We have to take O be the origin. Let A and B be 2 points. Let A and B be 2 points. Let P be the point which divides the line segment AB internally in the ratio ms to n. You see that? Oங்கிறது origin, A, B, 2 points we have taken, and the third point P, it divides the line segment AB internally, that is P lies inside the line segment AB. So internally in the ratio ms to n. If it's so, we are going to find the position vector of OP. Position vector of OP. That is position vector OP vector. Or position vector of the point P is denoted as OP vector. How it will be written? M into B vector plus N into A vector divided by M plus N. This result you should know. Okay, see, O be the origin, A and B be 2 points. Here we have taken the point P divides the line segment AB internally in the ratio ms to n. So we are going to find what? OP vector, that is which point divides the line segment whose position vector is going to be found. Okay, that is OP vector is equal to M into B vector plus N into A vector by M plus N. Okay, so see that here O be the origin, so OA vector is the position vector of A is A vector, and the position vector of B, that is OB vector, is equal to B vector. Here what is given? AP divided by PB. PB is equal to M by N. Just cross multiply. NAP is equal to MPB. Here we are going to apply the vectors. Okay, vectors apply பண்ணும்போது they should have the same direction. AP and PB both having the same direction, so you can apply the vectors. If they are in the opposite direction means you have to put minus. So your AP and PB, they are in the same direction, so I apply the vectors on both the sides. M and N are scalars. Okay, see, by using position vector I am going to write AP vector. So how it will be written? Position vector, position vector of the second point minus position vector of the first point, that is OP vector minus OA vector. M into here position vector of the second point minus position vector of the first point. So if you multiply NOP vector minus NOA vector is equal to MOB vector minus MOP vector, that I have written. So minus MOP vector, you bring it to the left side, it will become plus. Already NOP vector is here. Bring this minus term to the next side as plus. So OP vector, from these two it is common. If we take it out, M plus N is equal to MOB vector plus NOA vector. So OP vector is equal to M. What is OB vector? It is B vector. What is OA vector? A vector. So OP vector is equal to MB vector plus NA vector divided by M plus N. If it's so, you see the section formula, external division. That means this P, it is not lies inside the line segment AB, it lies outside. So the same way, O be the origin, let A and B be 2 points. Let P be the point which divides the line segment AB externally in the ratio ms to n. Then OP vector is equal to, you see that, MB vector minus NA vector divided by M minus N. Okay, so internal division means in between you have to write plus, external division in between you have to write minus. So see that M and N is equal to 1. So M is equal to N is equal to 1. So this is here 1, 1. Okay, so in the place of M1, if we substitute, it is OP vector is equal to B vector plus A vector divided by 1 plus 1. What is that? 2. if P divides the AB in the ratio 1:1, P is the midpoint. So therefore, the position vector of the midpoint of the line joining the points A and B. The position vector of the midpoint, which is the midpoint now, P is the midpoint because it divides equal ratio. So P is the midpoint. So OP vector is equal to, what is it? A vector plus B vector by 2. Okay, what is that? OP vector is equal to A vector plus B vector by 2. Okay, using this we are going to learn the theorem medians of a triangle or concurrent. Okay, see, medians of a triangle or concurrent. Concurrent means all the medians pass through the same point. All the medians pass through the same point. So first we should know what is the median. Median is the line segment joining the vertex to the midpoint of the opposite sides of the triangle. So take the first vertex A and the opposite side of A is BC. On that BC you have to take the midpoint. So therefore AD is one median, another median BE, the third median CF. The line joining the vertex to the midpoint of the opposite side, that is called the median. So here ABC, I have taken a triangle. OB the origin. OA vector is A vector, OB vector is B vector, OC vector is equal to C vector. So three vertices. So we have taken the position vector. Here, what is the median? AD, BE, CF. They are nothing but the medians. If it's so, D, E, F, they are the midpoints. D is the midpoint of BC. E is the midpoint of AC and F is the midpoint of AB. Now we are going to find the midpoint. So you see that using the section formula, D is the midpoint of which one? BC. So it is BC. Okay. D is the midpoint. Midpoint means it divides 1:1 ratio. So we are going to use in section formula, we are going to find OD vector. So எந்த point the line divide பண்ணதோ அதோட position vector. Position vector means you have to write the origin. O has to be started. So OD vector. So how to write? Take this number. Section formula if you want to use, your OP vector is equal to what it is? M into B vector plus N into A vector by M plus N. Okay. So see now 1 into C vector. Okay, so C vector plus 1 into OB vector. OB vector is B vector by M plus N. 1 plus 1 is 2. So OD vector, how we can write? C vector plus B vector by 2. Otherwise it can be written as B vector plus C vector by 2. Okay, in this way you can write. So D is the midpoint of BC. Means D divides BC in the ratio 1:1. So OD vector is equal to OB vector plus OC vector by 2. Okay. Then in the same way, E is the midpoint of AC. E is the midpoint of AC. So you have to draw AC. Okay. Which is E is the midpoint. So E divides in the ratio 1:1. So using section formula, what you are going to find? You are going to find OE vector. How it will be written? 1 into C vector. So C, that is 1 into OC vector. OC vector we have denoted as C vector. Plus 1 into A vector, that is OA vector. So A vector by 1 plus 1, that is 2. This can be written as A vector plus C vector by 2. Otherwise, A vector can be written as OA vector plus OC vector by 2. F is the midpoint of AB. So OA vector can be written as OA vector plus OB vector by 2. Okay. So we have found the position vector of the midpoints. Next, we will take the first median. What is the first median here? The median is AD. AD is the first median. AD we have taken. Okay. AD. On that, we'll consider one point G1 be the point on AD which divides AD internally in the ratio 2:1. We'll take the ratio 2:1. So here we are going to use the section formula. So using the section formula, what we are going to find? We are going to find the position vector of the point which divides AD. So which point divides AD? G1. So we are going to write OG1 vector. So how it will be? Take this ratio 2 into, here D is there, so 2 into OD vector plus 1 into OA vector divided by 2 plus 1. So here OD vector already we have found. So on that you have to substitute OD vector. So what is our OD vector? OB vector plus OC vector by 2. So when you substitute this 2 and this 2 getting cancelled. So the numerator is OA vector plus OB vector plus OC vector by 3. So the OG1 vector is OA vector plus OB vector plus OC vector by 3. In the same way, take a next point G2 on the second median. What is the second median? AD is one median. The second median is BE. So BE. So G2 be the point on BE, divides it internally in the ratio 2:1. So using section formula, we are going to find the position vector of G2. That is nothing but OG2 vector. How it will be written? Take this ratio 2 into OE vector plus 1 into OB vector divided by 2 plus 1. Here already we have found OE vector. So OE vector is what? It's E is the midpoint. So OE vector is OA vector plus OC vector by 2. So when you substitute this 2 and this 2 getting cancelled. So OA vector plus OB vector plus OC vector by 3. Similarly, in the third median, we'll consider. Similarly, we'll get OG3 vector is equal to OA vector plus OB vector plus OC vector by 3. From the three results, they are equal. The position vectors of the points are equal. That means G1, G2, G3, they are not different points. They are one and the same. And it is denoted by G, which is called the centroid. So, OG vector is equal to OA vector plus OB vector plus OC vector by 3. What is G? They are not 3 points, they are one and the same. It is denoted as G, means all the medians pass through the same point. So therefore the medians of a triangle are concurrent. So the meeting point of all the median is nothing but G. G is called the centroid. So the position vector of the centroid is OG vector. The answer is OA vector plus OB vector plus OC vector by 3. Thank you, students.